In this video, we are going to learn about dot plots. Let's begin. So, a dot plot is a visual display of data using a number line and dots to represent each data point. The data that repeats itself the most is often is the mode. In a dot plot, the mode is the tallest value. So, let's take a look at this first example. A survey in the sixth grade class asked students to record the number of devices they had in their home. The information is recorded in the table below. So, number of devices in the home, 0. We had one student had 0 devices. 2 had 1 devices. 4 had 2 devices. 5 had 3 devices. So we're gonna use this data in the table to make a dot plot, then answer the questions that follow up. So I'm looking at this data, and frankly, it's kind of hard to read. Like, what do you notice about the shape of the dot plot? Where do you think, say, the most of the data lies? When we look at this, it's a little bit trickier, but if I put it on a dot plot, it actually makes it a lot easier. So the number of devices is going to be what I'm going to put on the bottom. So number of devices, and 0 is the smallest, and then maybe 1, then 2, then 3, 4, 5, 6, 7, 8, and 9. I'm actually going to use red. So 1 student had 0 devices, and 2 had 1. Now notice my dots are kind of like evenly spaced in the sense that, like, well, I'll give you an example of a bad one. 4 of them had 2, so what I don't want to do is put the first dot down here, then 3, and then 4. Like, you don't want that. You want the dots to be about the same size, about evenly spaced either way. So if I'm going to do 4 dots, I'm going to keep my first dot. I'm going to make my first dot up here, not down there, okay? Because that way it's just a more useful representation. The second dot, again, is going to be right across from that one. It's not going to be down there. It's not going to be way on the side. So, like, right over there, lined up. So 1, 2, 3, and then hopefully they're evenly spaced. I don't have too many. Wait, I have 7. Maybe I should move them all down a little bit. You know what? In fact, I think I will. I'm going to move this down a little, and then move that down a little, and then move that down right there. And I guess these should also be bigger, just like the first ones. 4 kids said they had 2. Let's do 5 kids had 3. 1, 2, 1, 2, 3, 4, 5. 4 kids had, 7 kids had 4. 1, 2, 3, 4, 5, 6, and 7. And 5 kids had 5. 1, 2, 3, 4, 5. 4 kids had 6. 1, 2, 3, 4. 2 kids had 7. 1, 2. 2 kids had 8. 1, 2. And 1 kid had 9. So, what do I notice about the shape of the dot plot? List any other observations in the space below. I would say the data is evenly balanced on both sides. The most kids, the number of devices that's most common is like 4, and the numbers closest to 4 like 3 and 5, and then as you get further away from the most common number, you have fewer and fewer students. So, like, 1 kid had 0 devices and 1 kid had 9 devices. So very few kids had, like, not that many, and very few kids had, like, a lot, right? So one thing we could say is the data is pretty even. Data peaks at 4, had 4 devices, and is evenly balanced on both sides, on both ends, both sides. There we go. Where would you say that most of the data lies on the dot plot? What is the median of the data? I would say most of the data is in the middle at 4. Most in the middle, which is at 4. So the middle is like 4. So the median number of devices, if I wanted to look at this and figure out the median, you kind of look at that and you can cross off like one from each end until you get to the middle. So like 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9, 10, 10, 11, 11, 12, 12, 13, 13, 14, 14. All right, and as you can see, you're going to start scratching from the middle, but like they're all 4s. So the median is going to be 4. So you can figure out a median using a dot plot that way. All right, let's talk about the spread of data. The variability in the data points describes how far apart the data is from one another. This can be represented by the range. So the range is the difference between the highest and the lowest number. So we would say, oh, 9 minus 0, the range is 9, or between 0 and 9. The center of data, let's talk about the center. The median and the mean both represent the center of data. When the data is skewed, then the median is the best representation of data. When the data is symmetric, then the mean is the best representation of data. So what do we mean by symmetric? Well, let's look below. Data can take on 3 different shapes. So this one we would consider symmetrical. It's kind of even on both sides, like, ooh, kind of makes a nice hill, symmetrical. And frankly, if it's symmetrical, median and mean are probably both great. We would say this is skewed, this one right here, skewed. We'd say this is skewed to the right, skewed right, which seems kind of odd because, you know, when I look at this, I want to say, oh, it's skewed to the left because there's more stuff on the left. But actually what skewed means is like, you know, like when it's skewed to the right, there's fewer things on the right. Some students said, oh, imagine like a skewer, which is like a pointy stick. Like if this was like a blob and you were like to poke the blob, it would just like, oh, go away from that. So like skewing it on the right so that it like kind of moves away from your skewer. That's one way to think of it. But yeah, that's skewed to the right, which means fewer data points on the right. This one right here, the third one, we'd say that's skewed left. So if there's any kind of skewing, then the median would be a better measure of center than the mean. All right, let's go to the next page. So we want to use our understanding of dot plots and statistical data to answer the questions below. The Ecological Society sampled the green iguana population and made note of the length of each iguana sampled. The data is displayed in the dot plot below. So we've got length of the green iguana. Looks like one is 12 inches, another one's 13. We got 3 of them, which are 14 inches, 2 which are 15, 3 which were 16 inches, 2 which were 17, 2 18, and 1 19. So what's the mean? To find the mean, you gotta add up all the numbers, which it's gonna be a lot. So I'm gonna write it down here. So the mean, in order to do the mean, you have to add up 12 plus 13 plus 14, 14, 14 plus 15, plus 15 plus 16, 16, 16 plus 17, plus 17 I'm gonna have to use another row, plus 18 plus 18 plus 19. Add all that up and you divide it by How many dots are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So, oh my goodness, this is just 15. So all of that divided by 15. When I add all that up, I get 234. I'll write it on the side. 234 over 15, which turns out to be 15.6. So the mean is 15.6. What is the range? The range is the biggest number minus the smallest number. So that is 19. Let's use a different color. That's going to be 19 minus 12. And 19 minus 12 is 7. What is the median? That's the middle number. Let's do the middle number by scratching off the sides. 1, 1, 2, 2, 3, 3, 4, 4, 5, left, 5, right, 6 left, 6 right, 7 left, 7 right. Looks like we have a single number because I've scratched 7 on each side. And the number in the middle is 16. So the median is 16. And the interquartile range. The interquartile range is it's the middle of both of the medians and the mean. So, actually, it's probably best to do it this way. So, if I look at the median, I have, it's like the median of each, the first half and the second half. So, if I have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Actually, I got that wrong. So if I scratch off 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So there we go. So now I have 7 on the right and 7 on the left. 2, 3, 4, 5, 6, 7. So I need to look at these 7 numbers and find the median of those. That's how I find the interquartile range. So let's use pink. Cross it off. Let's do this one. 2, 2. And then it looks like I'm in the middle already. So the interquartile range, the first lower quartile is 14. And look at the upper quartile. Scratch this one off. This, 3, 3, and it looks like 17 is going to be our upper quartile. So it's 17 minus 14, which gives us an interquartile range of 3. So, based on the shape of the data, which measure of center is the best representation of the length of the green iguana? I'd say both the mean and the median are pretty close. The data is symmetrical, so I guess technically the mean is best, but so I would say neither one is particularly awesome or better than the other. So mean and median are close. But if you're going to say, well, this is symmetrical, therefore the mean is better, then you can say that. Let's take a look at number 3. A local neighborhood is seeking to become certified in energy efficiency. The efficiency scores of each home are displayed in the dot plot below. So it looks like this is not symmetrical. It looks like it's skewed to the left because there's fewer things on the left. Let's answer the question. So the peak score is which score is the most common. That's going to be 68. It's not the highest score, but the most common score. The shape of the data distribution is skewed to the left. So skewed left. And the range of scores is between 72 minus 60. So it would be 12. So label each of the following statements as true or false. A total of 20 homes were rated. Now, how would I know that? Well, I count the dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So that's false. 22 homes were rated. Exactly half of the ratings were greater than 66, so let's look at the scores that were 66. These are the scores that are 66. Let's say 22 total. So exactly half the ratings were greater than 66. That means at least 11 would be greater than 6. Or not at least, but exactly 11 are greater than 66. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that is also false because there are 12. 12 are greater than 66, and that's more than 11. The most common home rating was 66. That is also false because the most common is 68. Let's look at number 4. Mr. Tips asked the students to sketch a dot plot that was symmetrical and had data that was close together. Which students completed the task correctly? So I would say this one. The dot plot is symmetrical, and this one is also symmetrical, but in a different way. Now, the data, is it all close together? Well, yeah, the data is close together. You don't have like data all like one over here, one over there, and then a couple scattered everywhere. They both did their data close together. So both Sarah and Javon had data that's both symmetrical and close together. Now, Sarah peaks in the middle, and Javon has data that peaks in 2 different places and is low in the middle. So they are very different kind of dot plots, but they both are still symmetrical, and the data is close together. So that's our lesson on dot plots. Go ahead and try to answer some dot plot questions on your own. Good luck.